difficult for you. All right, if we don't have any questions, we're going to talk about reviewing for the final, and I'm going to cover the first 4. Okay, this is review for the final. I think I have the wrong pen here. Okay. All right, number 1. On number 1 on the final, it will say graph the function. And this is f of x equals the absolute value of 4 minus x. And I will tell you, whatever one you have on the test will look just like this. It won't be 4 here probably. It'll be 3, or it'll be 2, or it'll be 7. But I expect the rest of this to look just like this. Some number minus x. Okay? Now we know about shifts and we know about reflections. But to be truthful with you, and I have a little bone to pick about this, that we have not done a homework problem exactly like this one, because this minus is in front of the x that's on the inside, and that's a reflection across the y-axis. Everything else had a minus outside that we did, and that's a reflection across the x-axis, which is what we're used to. So my idea for this one is for you to graph this one on your calculator, this very first one, and we'll go back over it again. Just remember to just pick up your calculator and graph it, and then follow it. Follow which one it is. Now, there will be choices. It's multiple choice, so it will give you multiple choice options for your answer. I think I've already gotten this one in there. I do. Absolute value. Let's review on how we.
I'm late.
Who is that?
Tamala.
Okay. Hi, Tamala. Okay, I got you marked. We're reviewing for the final, Tamala. All right.
Shaquaila here too.
Okay. Thank you. I'll mark you here. If you go to your graph and remember how to get absolute value, that'll be the hardest part. To get the absolute value, one of the easiest ways to do it is hit second and catalog, which is the 0 key, and that very first one says ABS, which is absolute value. Second and catalog gives you absolute value. And put it in there. I'll see it'll make the little marks. So then you just put the 4 minus x inside there, and then you graph it. And you can see that it comes down over here at 4. Now you would think because this shift is inside and it's a positive that it would actually be over here, and it is. But what's happened is it used to be over here, and what's happened is it's reflected into this y because of this minus. It's reflected into the y. So that's what happens. That's how it ended up over there on that side. We didn't do a single problem like that. All of ours were reflections into the x's. So I'm going to see, I don't want to do it now because we've already published. So many of us have already started reviewing for the test. We don't want to change the test questions now. So I'm just telling you on this first one, graph it on your calculator, and they'll have pictures of these. There'll be one like here, like you think it might be. There'll be one down here. There'll be one over here. And there'll probably be one that's down here on this side. And so you pick the one that is the picture. So you don't have to actually go into your tool and graph. You'll pick the one that is the answer. Any questions on that? Okay, this one right here, you need to graph. Everybody can do number 1, right? I need a yes for somebody. Okay.
Yes.
Let's do number 2. Number 2, it says find f of 0 when f of x equals x squared minus 4x minus 3. And again, this might say f of -1 or f of 3 or f of 7. This might say x squared. It's probably going to say x squared. This might be 5x or 2x. This might be 7 or 3. But it's going to be in this form, and you stick this value for 0 in these x spots. I think all of you have done this enough that you can do it. You substitute 0 in for x. So f of 0 would be 0 squared minus 4 times 0 minus 3. And that's going to be 0 minus 0 minus 3, which is -3 for your answer. Okay, everybody can do that problem. Any questions?
No, ma'am.
Okay, good. All right, let's do number 3. This is again review for the final. This is this is probably the easiest question. Will be this number 3. If you want to jump to number 3 and do it first, you can. Is this graph a function? And they give you a picture. The one that's on our example one looks like this. It's a parabola that's upside down. It's reflected from it used to be a smiley and now it's frowning. It's reflected into the X. But I need to know what I use to figure out if it's a function or not. Does anyone remember what we use?
Vertical line test.
That's right, the vertical line test. And if you don't remember that, that's when you draw vertical lines down and see how many times each time you draw a vertical line, it's going to cross your graph. And if it only crosses it in one spot every time you draw a vertical line, then you write, yes, it is a function. And actually, they have 2, one that says yes and one that says no. And of course, you're going to circle the one that says yes. Okay, are we 3 out of 3 so far?
Yes, ma'am.
Yes.
Okay, everybody can do those 3. All right, let's try this one. And I'm going to go a little bit slower on this one so you can write it down. I think everyone can do this, but this is a harder problem than the others were. It's 4x plus 2y plus z equals -11. 5x minus 5y minus z equals -37. 4x plus y plus 3z equals -21. And it says solve. Okay, does anybody recall from having the course and thinking back, not to this test, but the test before this one, how did we solve a 3x3 problem like this? Anyone remember?
Matrices.
That's right, it's matrices. So you write x, y, z equals, and in the body, which is going to be our matrix A, we put 4, 2, and this z has a 1 in front of it, remember. So that's a 1 coefficient for that one. Then 5, -5, -1, 4, 1, 3. There's a 1 in front of that z and a 1 in front of that y. Now, what do we have to remember that goes right there in that spot, and we will miss it if we don't put it there? What is it?
The inverse.
The inverse. You have to hit that x to the -1 key to get that inverse. And then our other matrix is -11, -37, -21. This is going to be matrix A, and this one is matrix B. All right, grab your calculator and let's see if you can remember how to put those values in your calculator. Okay? All right, grab your calculator. Go to matrix. Does anybody remember where the matrix is?
Second matrix.
Now you have to do second, and this x to the -1 key above it is the matrix.
And then you go to edit.
And then you have to move over because you've got to put these numbers in here. So you move over to edit, and you're ready. A is highlighted. Now, if you've been doing this in your class and we haven't changed to 4x4s or 3x3, 2x2s or anything else, you should already have your dimensions in there. See, that 3x3 is already there. Just don't start putting your elements in there. Make sure you skip that 3x3 because that's the dimension, 3 rows and 3 columns. Now you're ready to put in the elements. So do 4, enter, 2, enter, 1, enter, 5, enter, -5, enter, -1. Remember to use the negative key down by the enter button. Okay, then we have 4, enter, 1, enter, 3, enter. How do we get out of this?
Second quit.
Is it second mode?
Second, and that mode button is the second and quit, and it gives us a blank screen there. Okay, now we're ready to edit B. So go to matrix, that'd be second, and that x to the -1 key is where the matrix is. Go over to edit, but this time I have to go down. I've already entered A. I've got to enter B. So I hit enter and let it know that it's a 3 rows by 1 column. -11, enter, -37, enter, -21, enter. Now, if you're real careful when you do them, you won't have an error. If you get some crazy decimal number, it's probably an error. Now, how do we get this? Matrix A, inverse, matrix B. How do we do that?
Second matrix.
Second matrix.
Press
Whoops,
enter.
did the wrong one and did the y equals. Let me get out of this.
Second quit.
Thank you.
There.
Second matrix. I guess I better put my glasses on so I can see here.
Then you
Now
try
A's
that.
highlighted. I've got my stuff in it. I just need to hit enter. See how it
Then
puts A there?
Then the X inverse key, the X -1.
X inverse.
Second matrix. B.
Second matrix down to B. And see, it looks like I have here A inverse B. And then I just hit enter and it gives me my values. -4, 4, -3. That's my X, Y, and Z. Okay, how about that?
And then also too, if you plug those in, it should answer each one if you wanted to
Yes,
check
if
yourself.
you want to double check yourself, that's correct. If you use the -4, 4, and -3, and you plug those in for X, Y, and Z, when you do that on this one, you should get a -11. When you do it on this one, you should get -37. And when you do it on this one, you should get -21. And that double checks your work to make sure you're right.
Yeah. I like the problems where I can check my work.
Mhm. All right, that's 4. So far, so good. We have 100% on the final so far?
I hope so.
I hope so too. All right, let's do our poll for the day real quickly before we start doing our other information that we've got to do today. Let's do our poll. There are 2 questions here for you to do. Can you see the questions? Can you guys see them? There's 2 questions. To do my work in this class, I primarily use what kind of equipment? How many hours did you study for exam 2? And if you scroll down, I'm not sure it shows you all of it. It'll show you some more options on how many hours did you study. Okay, we have 1 person that has not voted. They may not have available equipment to vote. Let's look at this. Let me share your results so you'll know kind of what people are doing. To do my work in this class, I primarily use my laptop. So some people are using their personal computer, but most people are using their laptop. We don't have anyone with borrowed equipment from somewhere, although I know that some of you've had to go to a friend's house or a relative's house to do some of the work from time to time. All right, number 2, how many hours did you study for exam 2? Primarily, most people studied 1 to 3 hours. Some people studied more than 5 hours for it, 10%. Half of you studied in that second one. Any questions or comments about how many hours you studied? Did it pay off for you to study a lot? You know, do you have any comments on how you did and if it paid off the way you did it? Yes? No? Okay.
Which sections are, we're doing 8.1 today, is that correct?
Yes.
Okay.
And
wanna
8.2.
make sure.
We're going to do 8.2 as well.
Okay.
All right. Let's start in for tonight. And I'll do my very best to go slowly enough. Let's see. Did Selena come in or Margaret or Chandra? Chandra here? Yes, I see you, Chandra. Okay.
I put it in the chat too when I came in.
I did see your chats pop up. I sure did. I forgot to list you. Thank you for letting me know. All right, this is for 8.1. We're going to try to do 8.1 and 8.2 tonight. And for this section, there's a lot of terminology that you're going to need to know. It's not hard. It's just a lot of terminology that we're going to need to know. And I'm going to actually write them out so that you'll get used to seeing these words. Leading term. A term is made up of several things like a coefficient and a variable and sometimes an exponent, and there might be a sign in front of it, plus or minus. But a leading term looks like that. That one is 3x squared. And when your polynomial is written, if it's written in descending order, Descending order means that you've got the top exponent first. It is the first term. So if I have a problem that's like -7 plus x to the fourth minus 3x to the second plus 5x, that's a polynomial, but it's not written in descending order. So what I want to do is write it so that the highest exponent is first. Well, it looks like the highest exponent is x to the fourth. So I would write that one, and then I've got an x squared term, and then I have an x term, and then I have a constant. This is called the constant because it doesn't have an x with it. Now I have it in descending order, and when I do that, it's the very first term is called the leading term. Okay? The whole thing is called the leading term. That's very important to us. It tells us what direction the polynomial is going to go. It tells us what shape it has. It tells us a whole bunch of things. So that leading term is the one in the front if you write your polynomial in descending order. Okay, let's do another one. There's another one that's called leading coefficient. A coefficient is a number, okay? And if it's not written there, it's understood to be 1. So it's the number including the sign of the first term. If this is all I have for this one right here, and I don't have anything else added or subtracted or anything, then for this one, my leading coefficient is 3. It's the number that's associated with that term. In this second example that I have here, x to the fourth, my leading coefficient for this one is not, there's no number there, a big number. There's an exponent, but it has a name. It's not called a coefficient. It's the big number out front. So it's understood to be a 1 there, and it's a positive 1. So if I had -3x to the fifth plus 2x to the second minus 5 for my polynomial, the -3x to the fifth would be called the leading term. The leading coefficient would be -3. And that -3 is going to turn my shape upside down like it always has before. That's what it's going to do. Okay, any questions on leading terms and the difference between a leading term and a leading coefficient? The term has the x with it and the little exponent. The coefficient just has the big number that's in front with the sign. Okay, let's talk about the degree. The degree of the polynomial. The degree of the polynomial is the degree, and that means the exponent, of the leading term. So it's important to know what the leading term is because you've got to have the degree of the exponent. So let's look at these that I have here. The degree of this second example, since I've written it in descending order, I would say the degree is 4 because it's the highest exponent of all the terms. Each term has its own degree. Like this one is a degree 2. This one is a degree 1. It's understood to be a 1 there. And this is a degree of 0. There's no x on it. Up here in my 3x squared, I would say that degree is 2 because of the little exponent 2. In this case down here, my degree would be the degree of the highest one, the leading one, which is 5. So the degree is 5 there. This one has a degree of 2 and this one has a degree of 0. But my highest one, the one of the leading term, is 5. So that's called the degree of the polynomial. And that will tell us what shape it is. If it's degree 2, it will look like a parabola. If it's degree 3, it's going to look like a cubic. If it's degree 4, it's probably going to look something like that. And so on, so that you can tell by the degree the shape of the graph, the polynomial. Okay, now one more thing in this section that before we start changing the direction of what we're doing here, it's called the constant term. The constant term. The constant term is the one with no x or variable. So if I had 2x squared minus 3x plus 5, 5 is my constant term. And let's go back over this. The leading term would be 2x squared. The leading coefficient would be 2. The degree of the polynomial would be 2. And the constant term is 5. The constant term is also the y-intercept. So this particular graph is going to cross 1, 2, 3, 4, 5. It's going to cross at 5. That's because that's the number on the end that's called the constant term. That also identifies the y-intercept. So that's where it's crossing the y-axis. It's crossing at the point 0, 5. Okay, let's talk about types of polynomials. There's a constant polynomial, and that's like f of x equals 3 or y equals 3. That's going to be a line where y is equal to 3. That's what that looks like. Y equals 3. It's a constant polynomial. It goes straight across, doesn't go up, doesn't go down. Remember when we were doing intervals, how we had constant intervals? That's because that was straight across. So there's such a thing as a constant polynomial, which means it's just equal to a number. If I did the leading term, it would be 3. If I did the leading coefficient, it would be 3. If I did the degree of this, there is no x, so the degree would be 0. And if I did the y-intercept or the constant, it would be 3. All right, the next one up from that constant is linear. Linear is like y equals x plus 2. We already know that's a line. That's why it's called a linear polynomial. It's a line. So if I were to graph this one, I could go up to 2 and then use my slope, 1 up and 1 over. I could put it in my calculator. I know that that's a linear one that looks like that. If my x is negative, it's going to slant the other way. That's called a linear. It's to the first power. This one is to the 0 power. Okay, let's do all those things. The leading term is x. The leading coefficient is 1. The degree of the polynomial is the highest exponent, which is 1, and the y-intercept is 2. Any questions on that? Some of this is pullover from what we already know. The next one is called quadratic. We've already been talking about quadratic polynomials. We know those make parabolas. This is to the second power. Okay, this would be something like f of x equals 2x squared minus 3x plus 4. And what that's going to do is that's going to be a polynomial. It's going to cross over here at 4. I know that it is. It's going to cross at 4 because that's the number on the end. And it's going to smile because this is positive. But it looks like that. It's called a quadratic polynomial. So the leading term on this one is 2x squared. The leading coefficient's 2. The degree is 2. And the y-intercept is 4. The number on the end. Okay, what's after quadratic? We've done this before, so what's after quadratic? Anybody know?
Okay, can you put that page back for just a second? I'm sorry.
It's okay.
I didn't get the last thing you had.
So we have constant, has no y, no x's with it. It's just a number. It's to the 0 power. Because I could put x to the 0 in there if I wanted to. X to the 0 is just 1, and 1 times 3 is 3.
Cubic.
Cubic is next. Are you ready for me to move it? Yes? Okay. Cubic.
Yes, ma'am.
Okay. Cubic is to the what?
Third power.
The third power. And that would be something like f of x equals negative 3x cubed minus 4x squared plus 5x minus 7. Something like that. It's to the third power. It's called a cubic. All right. So let's do that. All those things on this one. The leading term is this whole thing there, minus 3x cubed. Somebody needs to mute yourself, please. The leading coefficient is negative 3. The degree is the exponent of the leading term, which is 3. And the y-intercept, or the constant, is negative 7. Okay. All right, there's one more that we haven't done before, and this is called quartic. Quartic. It's to the, what do you think?
Fourth.
It's to the 4th power. And it would be something like f of x equals negative 2x to the 4th plus 3x to the 3rd minus 2x squared plus 5x. Something like that. It's to the 4th power. Okay, so let's do these things. Leading term would be negative 2x to the 4th. Notice it's got the x and the exponent and the coefficient all in it. Leading coefficients, negative 2. Degree is what?
4.
to the fourth. What's the y-intercept on this one? This is tricky.
Would it be 0?
It is 0. See, it's got an x term, but it didn't have that constant term. But I could put plus 0 on there. So my y-intercept is 0. When all these have x's and there's no constant term, the constant is 0. Okay? More than fourth power are just called polynomials. So to the fifth power and the sixth power and the eighth power and the 11th power, those are just, they don't have special name. Well, they do, but they don't have special names for this course. They are called polynomials. Okay, anybody not finished with this?
What are some of the names of the other polynomials?
Well, there's a septinomial. There's an octa. There's one with an octa, which would be 10. There's one with a dodec. They're just, they go with the names of what the number is in the exponent. And so we just don't ever use them past quartic because I don't know. We just don't use those polynomials very often until you get into higher mathematics. And so we don't usually call them anything but polynomials after this. But you can look it up. You can look up what the names are.
Sounds like a lot to remember.
Oh, you don't have to remember it. You only have to remember 4 of them. All right, let's talk about end behavior. Okay, we already know that if we have f of x equals x squared plus 2x plus 4, that thing is going to be a parabola and it's going to smile. How did we know that?
It's x squared.
And we looked at the leading term. And because this was positive, it made it smile. Do you remember that? All right, so there are some rules for the end behavior. If you have an even exponent, and this is on the leading term, I'm generally talking about this leading term here, an even exponent and a positive coefficient, then the thing is going to have end behaviors, and you don't put anything in the middle. Looks like that. So even exponent, positive coefficient, that could be like 2x to the 4th plus something, something, something. It could be like 3x to the 6th plus dot, 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 something, something, something. Any of those, okay? It's got to be an even exponent and a positive coefficient. And the ending of that curve, whatever's in the middle, like this 4th, I don't exactly know what's going to happen here in the middle. And sometimes they put these little curly Q things in there. But whatever happens in the middle, something. But I know the end of it, they're both going to stick up, whether it's an x to the 6th or an x to the 4th or an x to the 8th or an x to the 10th. If it's a positive coefficient and an even exponent, the ends of it are going to both go up. All right, now you know this one because we've done it before. If you have f of x equals negative 2x squared plus 3x minus 2, you know what that thing's going to do because we've done this before. It's a parabola, and because it's negative, it's going to frown. We know what that looks like. So if you have an even exponent and you have a negative coefficient, then what's going to happen is it's going to frown. The end behavior will be going down. So if I had negative 3x to the 4th plus something, 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 or a negative 2x to the 6th, yes, plus dot, 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 then those are even powers, even exponents, but they have negative coefficients. The negative coefficient is what turns that stuff upside down. So we don't know exactly what happens in the middle, but we know the ending behavior are both pointing down. Even exponents, positive points up, negative points down, they both go the same way. Are we good with that? All right, so if we have even, positive, negative, what's the other two options? What if we had f of x equals x cubed plus 2x minus 3? Do you know what that would look like? Remember doing those cubes? They look like something like that. They might even have a hump in them, but they'll look like that. Notice how one goes up and one goes down. See that? So let's think about what the end behavior of these look like. You're talking about this leading coefficient here, and you have an odd exponent, and you have a positive coefficient. Then it's going to be one up and one down that goes this way. The down comes down on the left side, the up goes up on the right side. So if I had 2x to the 5th plus something, 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 or I had 5x to the 7th plus something, 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 or 4x to the, what else can I do? 11 plus something, something, something. Notice that the exponents are all odd and the coefficients are all positive. So I don't know what this thing is going to do in the middle, but I know the ending behavior, this is why this is here, the ending behavior will be going down to the left, going up to the right for all of those. Okay. I hope you're writing notes because I'm going to ask all of you some questions in a minute. Suppose you have a negative 2x cubed. Let's just do that. Nothing after it, just negative 2x cubed. What does that do to your nice little cubic curve?
Does it go down to the right and up left?
Yep. Goes up left and down right. It flips it. So this is when you have an odd exponent and a negative coefficient. Okay? So that would be like negative 3x to the 5th, or negative 7x to the 9th, or negative 10x to the 13th. All of those will do the same thing. They'll be up on this side with something in the middle and down on this side. That's what the ending behavior looks like. Okay, any questions on that? All right, we're going to see how well you do. I'm going to give you a second to copy this down or make some notes on this. I need you to do a little chart on your paper there. Any of you don't have paper? find you some paper and jot you down. And you can just put LT for leading term, LC for leading coefficient, D for degree, C for classification, EB for end behavior, and Y-intercept. And we're going to go down through this because this is what your assignment looks like. They're individually done, but we're going to do them all at one time. So I'm going to give you a minute to look at it. And let me see. Let me pick some people. Let's see, Brooke, if you could do one across. Corey, you think you could do two? Two's okay. Corey. Luke, are you there? I'm going to give you the hard one. Luke.
Yeah, I'm here.
Let's see. Amanda, could you do this one?
Yes, ma'am.
And Lori, are you there? Or
Yeah,
Sharon?
sorry, I was writing.
Okay, Lori, can you do maybe this one? And Billy, you want to do one? Think you can do one, Billy? Maybe. I don't know. Let me pick. Hi, Portia. I don't think I marked you here. Donovan's here too. Natalie. How about Natalie? Natalie, can you do this one?
I can attempt.
Okay. And let me see. Billy, are you asleep? Can you do one of these? How about Erica? Erica, can you do this one?
Yes.
Okay. Morgan, do I have you down for one? How about this one, Morgan?
Wonderful.
Yep, you got one with the square root, but it's okay. It's not much different. Chantel, can you do, you want me to give you a hard one or an easy one, Chantel?
Does that one problem say negative pi? I can't really read it.
It does say negative pi. Let's see. Chandra, you want to do that negative pi one?
No, but I'll figure it out.
Okay. I'm going to put you down. Let's see. Chantel, how about this one? If you're there, Chantel.
Yeah, I'll try that.
Portia, you want to do one?
No, I'm just watching and observing.
Okay. How about Kiana? You want to do one?
No, I'm just watching.
How about Donovan?
I'll do it.
Okay. Donovan, you've got that next to the last one. And let me find who's not done one that wants to do one. Margaret Davis. How are you, Margaret? I'm so glad you're here.
With the negative
I'm-
pi one, is
I'm
that
here, but-
x to the fifth?
I better do it.
Well, the negative, ask your question about that pi. What was your question?
Okay, so the one I have is, I know it's negative pi x to the 6 plus 5. Is that an 8 or is that plus x? Is it x to the 5th or x to the 8th?
This is an x to the 5th.
Okay,
This
okay.
one's fourth. This is just a plain X, and this is a 2.
Never mind.
Okay, let me make sure I've got everyone marked here. Danielle here?
I'm here, but this is Margaret. I'm here, but my computer been going in and out. I'm not gonna do it. I'd rather not do that one.
Okay. How about if I do that one? I'll do the last one. I'm brave.
I'll do it, Dr. Sullivan.
Who is that?
Astanika.
Okay. I forgot you. How did I miss you, Esnika? You could be doing all the hard ones. All right.
Last time you can-
What you've got to do is tell me the leading term, the leading coefficient, the degree of the polynomial, what kind of polynomial it is the end behavior going to be both up, both down, or one up and one down? And what is the y-intercept? So anybody have yours ready to do?
I do.
Who is that? Luke?
I believe I do.
Okay, Luke?
Is the leading term just 4?
Yes,
The leading coefficient is 4.
that's correct.
The degree is 1.
Nope,
Uh,
there's no x on it. If it had an x, it would be
Oh.
1,
0.
0.
And there's not, if I'm wrong, there's not a classification or an end behavior because it's just a straight line.
Is a straight line. So what's a straight line called?
Shoot.
When it goes straight across, we did that in intervals. What's it called?
Linear. Linear.
It is linear, but it has a special name.
Constant.
Constant.
Tricky.
All right. What does the end behavior on that funny looking line look like?
I honestly have no idea. I don't think I missed the end behavior part.
Okay, end behavior. Let's see what that looks like. 1, 2, 3, 4. It's going to be a line that goes across like that. If you want to look at the graph, so the end behavior is going to look like this. Okay, what is the y-intercept, Luke?
I knew the end behavior. The y-intercept is 4.
So what point would that be?
0, 4.
Good job.
I knew the end behavior. I was overthinking it.
Okay, anybody else have yours?
I've got the first one.
Okay, leading term.
-1 4th x to the second.
That's correct. Leading coefficient.
-1 4th.
Good job. Degree.
2.
Classification.
Linear.
Nope, not linear. It curves. It's got a 2 on it.
I'm just kidding, it frowns. It goes down on both sides.
And so instead of calling it a parabola, what's that other name they use?
Quadratic.
Quadratic.
Okay.
What does the end behavior of it look like?
Both down.
Both down. And what's the y-intercept?
7.
7. Good job. So what is the point?
It is 0, 7.
Good job. All right. Who else is ready?
I'm ready.
Who's that?
Astanika.
Astanika? Okay, Astanika's down here. What's your leading term?
2x to the 3rd power.
Good job. What's the leading coefficient? What'd you say?
2.
2. Okay, I'm sorry, I didn't hear you. What is the degree of the polynomial?
3.
What is the classification?
Cubic.
Good job. What is the end behavior?
It's odd positive, so 1 up, 1 down.
And what is the y-intercept?
-5, and the point is 0, -5.
Good job. All right. Anybody else have yours ready?
I'm ready.
I think I have.
Okay. Who was that first one?
Natalie?
Natalie? Okay, Natalie?
Okay, leading term is going to be negative 1/3 x to the second.
Yes.
LC is going to be negative 1/3.
Yes.
Degree is going to be 2.
Good job.
Class is going to be quadratic.
Good job.
Behavior is going to be a frowning face, the pointing down on both
They're
sides.
both going to point down.
And then the y-intercept is going to be 9.
And that's the point.
0, 9.
Okay, good job. All right, who else has one? Corey, do you have yours?
I think so.
Okay.
The leading term is negative 6x. Leading coefficient, negative 6. Degree is 1.
Good job.
In behavior would be a line, a constant polynomial.
It's a line, and this line's going to go this way, actually.
Oh, okay.
Okay, because it's slanted. Now, what is the classification?
Constant.
Nope, constant would be straight across. Constant straight across. It's linear, so, but it does have a place that it's going to cross the y-axis. Where is that? What's the number on the end without an x?
Oh, the y-intercept will be negative 9.
So that's 0, negative 9. Now you need to classify it.
I must have missed something. I can't remember what it would be called.
It's to the first power. So if it's to the first power, right here, y equals x to the first plus 2 to the first power is called linear.
Oh, linear.
Okay, who's next?
I can go next.
Okay, who's that?
Lori.
Lori?
So the leading term is negative 4x squared.
Okay.
The leading coefficient is negative 4.
Okay.
The degree is 2.
Okay.
It's quadratic.
Okay.
And it faces upside down.
Okay.
A frowning. And then the point is 0. The y-intercept 0, and it would be 0, 0.
Okay, that's great, except there's something wrong, Lori. You did what everybody does with these problems, and you'll do it on the homework too. What do you think you did?
It's not in descending order.
Oh my gosh.
Everybody look at that one that Lori did, because you will do, this is one of your homework problems, and you will do the very same thing. What's wrong
Is
with
that the only one that's listed like that? How did I miss that?
The degree is 4, or is that a 7, or is that a 3?
I had
All
the
right.
Joker problem.
So you did. That was a trick, wasn't it, Lori?
I'm the only one.
No, it's not the only one. There's one down here too somewhere. There's another one. Here's one down here. Chantel, you got one like that, so be careful. Learn from Lori's mistake. Okay, now do you want to change your answers, Lori?
Yeah, I'll redo it. I wish I had whiteout. Jeez. Okay.
So it's not negative 4x to the second. What is it?
X to the 4th.
X to the 4th.
Leading coefficient is 1.
Coefficient is 1.
Degree is 4.
The degree is 4. And now it's not a quadratic. What is it?
Quartic. I cheated.
It's a quartic. Now, is it both going to face down still?
I think it's gonna face up.
Uh-huh.
Is it like the squiggle that goes up?
Yep. So they're both going to face up.
Okay.
How about our number on the end? Did our y-intercept change?
It's still 0.
It's still 0. So watch out for that. I'm glad Lori did that. I'm glad it was Lori, so she could handle that. But you have to be careful because not all of these are listed the way you want them. You have to list them in descending order. So Chantel, yours is like that. Be careful. All right. How about Amanda? Do you have yours?
Yes, ma'am.
Okay.
The leading term is negative 4x to the fourth.
Mm-hmm.
The leading coefficient is negative 4.
Okay.
The degree is 4.
Uh-huh.
The classification is quartic.
Mm-hmm.
It's the two ends pointing down for the end behavior.
Yes, because it's the negative leading coefficient.
And the y-intercept is negative 7 at a point of, so it'll be 0, negative 7.
Okay, good job. Okay, how about Erica? You have yours, Erica?
I do.
Okay.
The leading term is negative 1/4 x to the 4th power.
Okay.
Leading coefficient is negative 1/4.
Yes.
Degree is 4.
Yes.
Classification is quartic.
Mm-hmm.
Is that how you say that? End behavior, I think, is pointing both down.
Yes.
And then the y-intercept is 5. The point is, or the plotting point is 0, 5.
Good job. Okay, how about Morgan?
I'm gonna try. I don't know. Okay, so the leading term is negative square root 3x cubed.
Good job.
And then the leading coefficient, this I don't know. Is it negative 3 or 3?
Well, you got to use the square root. You can't take it out from underneath the square root. The square root of 3 is a number. It's 1.7.
So it would be negative square root of 3.
Uh-huh.
Okay. The degree is 3.
Uh-huh.
Classification is cubic.
Good job.
The end behavior, is it 1 up and 1 down?
1 up and 1 down, but it's negative, so it's going to flip it. It's going to be up this way and down this way.
Yeah. And then the y-intercept would be 4.
Uh-huh.
And then 0, 4.
Good job. Okay. Let's see. Chandra?
Okay. So I was confused about this. So I know pi is 3.4, so would it be negative 3.4?
You don't have to put the 3.14 in there. You just have to put the pi.
Good.
Negative
Okay, I didn't know. You know, math
pi.
can be tricky. So, okay, so negative pi x to the 6th.
Good job.
And then the leading coefficient would be just, is it negative pi?
Mm-hmm. Good job.
Degree would be 6.
Good job.
And the ending behavior will be, is it up to the right? No, up to the left and
It's
down to the
even.
right?
If it's even, they're
Yes.
both going to go the same way. They're either going both up or both down.
Both down?
Mm-hmm.
No, it's even, right? So it'd be both.
Even, but it's negative here, so that's going to make them both down.
Go down. Go down.
Yep.
Mm-hmm. And then the y-intercept is 2.
Uh-huh.
And then the ordered pair is 0, 2.
Good job.
Oh, I forgot the classification, polynomial.
Mm-hmm. Good job. Okay, Chantel, did you figure out that you've got one of those
that one
crazy
was
ones?
hard.
So which one is the highest degree?
Okay, you're gonna have to work with me now because y'all know I don't know this.
It's okay.
I'm trying to make sure I got the problem written down good, because every time I tried to write it down, somebody was always talking and it kept blanking out. So let me see. The leading term, is it 0.4 x to the 7?
Good job.
Okay. The leading coefficient,
Guys,
is
see
it
how she had to come over here and get this one because it was out of order? It's not in descending order. Okay, now what is your coefficient?
Is it 0.4?
Yes.
Okay. The degree, I got 7.
Good job.
And I didn't get anything else but classification and behavior, y-intercept, or the point. So
okay, well, if it's
I was
more
still
than
working on
4, if it's more than this quartic,
Mhm.
if it's more than that, then it's just a polynomial.
Okay.
Okay, how about the ending behavior? Since it's odd and positive. What did that odd and positive one look like? Odd and positive. Here it is, odd and positive. One goes up and one goes down, like that. You see that?
Yeah, I see it.
Ours is odd and positive. So one goes up and one goes down.
Okay.
Now, how about what are you going to do about your y-intercept since you don't have a constant term here?
I don't know. I didn't get that. I wasn't that far.
Okay, let's look up here at this other one this one didn't have a constant term. It didn't have anything added with a plus number here.
So would it be 0?
It's 0. When they're all of them have x's, then your y-intercept is 0. Okay?
Okay.
Good job. All right.
Thank you.
Donovan, I think you're it. Be careful. Yours is backwards too.
Yeah, so the term is -1/4 x the power 4.
Y'all see that? It's right there in the middle. It's not even on the other end. It's in the middle.
The leading coefficient is -1/4. The degree is 4. The classification is quartic. It's an odd exponent, both going down, and the y-intercept is 4, so it's gonna be 0/4. I mean, 0 is the x and 4 is the y.
Okay. Okay. Looks good. All right. Now that is pretty much what that homework is. In fact, these are problems from the homework. They
Can
don't
you
all
leave that there for a second?
They don't all ask all the questions. Some of them just ask what is a leading coefficient. Some of them just ask what is a classification. Some of them ask what's the end behavior. Some of them will ask what is the y-intercept. But that is the assignment that you'll be doing for that first part. I'll go over some of the others that are in addition to that. That is primarily the function of this assignment, is to learn the leading term, the leading coefficient, the degree, the classification, the end behavior, and the y-intercepts. Just be careful because they throw those in there when they're out of order. It's only the first term if it's written in descending order. Okay? Anybody else need more time to write? How are we doing? We almost finished. This chart is posted under content with all the answers in it. So if you want to go there and look, it's already posted there for you.
I'm glad you said that because a lot of times it look like kind of blurry to me. Then when you move the paper a little bit, then it'll start looking like real clear. So I'm glad you said that.
It's posted. It's the same worksheet. It's posted under content. It's under 8.1 lecture, and under the lecture part of it, this little charts there all filled out for you. Okay. All right. Let's see what else we have to know for tonight. That seems like a lot, doesn't it? But there are some other things, some things we already know, but it's going to come up in this section. It is the zero of the function. We've had this before, so this is not new. Okay, if you put the given number in for x and you get 0, then it is a zero of the function. So you're looking for something to come up with 0. So let me give you an example. If you have a function that is f of x equals x cubed minus 2x squared plus 3x minus 5, that's cubic. And the question says, is -1 a zero of the function? What would you do? Anybody know?
Plug in -1.
You just plug in -1. So I have f of -1 equals -1. Be sure you put it in parentheses. Minus 2 times -1 squared plus 3 times -1 minus 5. And all I did was plug in -1 in there for x. We've done this before. It asked the question a different way. It said, find the value of f of -1. Now it's saying, is -1 a zero? So it asked the question differently before, but you've done this before. You've done it the same way. So -1 cubed is -1 times -1 times -1, which is -1. -1 squared is +1 times -2 will give me a -2 in that second spot. 3 times -1 is -3. And then I have that 5 down there that's negative. So it looks like they're all negatives. It's not going to be 0. Looks like I've got 3, 6, -11. So this is not a 0. Makes a point. It makes -1, -11, but it's not a 0. It has to be a 0 to be a 0 of the function. Okay? That's pretty easy to do, I think. If you have trouble remembering the terminology, look back at this page and see if you can remember what to do. Okay, let me tell you a new word. I like this word. It's fun to say. It's called multiplicity. Multiplicity. You're going to find the multiplicity of each 0. And let me show you what these look like. F of x equals x to the 5th times x minus 2 to the 2nd times x plus 9. Those are factors. Those are not all multiplied out. So it'd be really hard for us to determine what that leading coefficient is right now because they're not multiplied out. Those are sitting as factors. And remember to find the zeros. We said each factor equal to 0. Okay? But you don't have to worry about the exponents. The exponents tell you the multiplicity. So you set each factor equal to 0 and solve. Don't worry about outside exponents. Okay? The exponents are the multiplicities. So those little exponents that's going to make the multiplicities. So I have this little x minus 2, and this little x plus 9. And this one really has an exponent up here. It's 1. So I'm going to set each one of those equal to 0. The first one is x equals 0. And M stands for multiplicity. The multiplicity of it is the exponent, which is 5. Okay? 5 is odd. So that means it crosses the graph at x equals 0. It goes across the graph. Odd ones cross, even ones touch. Okay? Let's try the second one. X minus 2 equals 0. I have to solve this one by adding 2. So I get x equals 2. I look at my exponent. My exponent is 2. So my multiplicity for this one is 2 from the exponent. Okay, that is even. If it's an even multiplicity, it just touches the graph at x equals 2. It's also called tangent, and I'm going to show you a picture of this in just a minute. The author uses the word tangent for touches. The third one is x plus 9 equal to 0. Again, I need to solve. We've done this before. We just didn't have the multiplicities on them. And the exponent on that one for my multiplicity is 1, because the exponent is understood to be 1. It is odd, so it crosses at x equals negative 9. Now, what this is a graph, and I graphed it earlier, so I kind of know what it looks like. Down here at negative 9, this graph comes down through here at negative 9, and it goes way down here somewhere. I can't even see the bottom of it on my graph. But then it comes back up, and it crosses at 0. It's going to come in here and cross at 0. Right there, that 0. And then it's going to come up and it comes down and just touches at 2. See how it just touches there? It crosses here at 0 because that multiplicity is 5, which is odd, makes it go through the graph. 9 was a 1, which is odd, so it goes through the graph. But at 2, the multiplicity was even. It was a 2. When it's even, it comes down and just touches the graph, which is called tangent. So that's the way the graph looks. What you're trying to learn from this is what is the multiplicity of each 0, and whether it crosses, intersects it, or whether it touches it. So what you're doing is using these exponents of these little groups. That's your multiplicities. And for the zeros, If the 0 has an odd multiplicity, the graph's going to go right down through that number, crossing across the x-axis. If the multiplicity is 2 or 4 or 6 or 10 or 20, then it's going to come down and just touch it at the graph. Doesn't go through it, it just touches it. Okay? What they will ask you is, what is the multiplicity of the 0? Is it tangent or does it cross the graph? Those are the kinds of things they will ask you. Any questions on that? Okay, is your mind too full? We have one more easy thing to do, and then I'll go as far as I can go with all of the assignments. We've answered most of them actually already, but most of the questions, but I'll answer the ones we haven't asked after we finish this section. This is actually 8.2, but it only has one thing in it that I think you can learn. Turning points. Sounds like a TV show, doesn't it? Turning point. Okay. This is a relative, maximum, or minimum. See, we've already had those terms before. Relative, maximum, or minimum. That's what that thing is. It's a turning point. We know what an x-intercept is. It's the point where the y value equals 0 and the graph crosses the x-axis. That's the x-intercept. And then real zeros. Those are things that are not i's. So we won't have to worry about using the quadratic formula because these are only real zeros here. This is the same for our information as the x-intercept. Okay? So we have to find the maximum number of real zeros. And we know that's equal to the maximum number of x-intercepts. And it's 1 less will be the maximum number of turning points. And let's just do an example. Let's just do a cubic curve here. There's 1, 2, 3 places that has x-intercepts. 3 places that have x-intercepts. Those circled places. There's going to be 3 real zeros. Those are the 3. Well, the turning point is going to be like the relative max up here and the relative min down here. But there's not 3 of those. How many of them are there? Somebody tell me. 2.
There's only 2.
There's 2 turning points. So every time you do this, and it's a whole set of these, where you have to say, how many x-intercepts could it possibly have? What's the maximum number? How many real zeros could it possibly have? And how many turning points could it possibly have? So we're going to do a little sheet, and I'm going to write these down, and we're going to do maximum number of zeros. Maximum number of x-intercepts. Maximum number of turning points. And there's only about 5 of them. These are from your homework. Can you read that? F of x equals x to the 5th minus x to the 4th plus 7. F of x equals x to the 11th minus 3x to the 7th plus 3x minus 2. F of x equals negative 6x minus x to the 7th. F of x equals negative 1/5 x squared minus 5. F of x equals negative x to the 5th minus 2x to the 4th. Okay. You want to find the leading term. That's when we had to do that a while ago. That's what tells you all these things. So I'm going to wait a minute and give you a chance to write those problems down. All right, we got to locate our leading term. So it looks like that. Our leading term is x to the 5th, looks like its coefficient is 1. Leading coefficient's 1. The power, the degree of it is 5. So you're using that exponent to determine the number of maximum zeros that thing could possibly have. So whatever this top exponent is what goes there. Since the maximum number of zeros equals the maximum number of x-intercepts, then what has to go here?
5.
5. Now the maximum number of turning points is 1 less. So what number goes there?
4.
4. Okay. In the second one, locate your leading term. Looks like it's x to the 11th. What's the maximum number of zeros?
11.
11. 11.
10.
10. Okay, let me pick somebody to do this one. Sequela, can you do this one? Are you listening? Are you with me? Okay, it looks like x to the 7th, negative x.
Can you hear me? I'm with you.
Okay,
So that was gonna be my first question if I had to go in descending order or not. But so if it's negative x7, then it's gonna be maximum number of zeros is gonna be 7.
And maximum
No,
number of x.
Sorry, it's gonna be 1.
No, it's you're right. It's
Maximum number. Okay, to the 7th power, and then because the coefficient would be 1. Okay, so then the x-intercepts is gonna be 6.
No, these have to be equal.
Or would that be?
So if this is 7.
Okay, so it's gonna be 7 as well.
7. Now this one is the one that's
okay.
different. What is it?
It's gonna be 6.
6.
That's gonna be 6.
That's good. Okay, Amanda, can you do this one?
Yes, ma'am.
What is it?
2, 2, 1.
2, 2, 1. Okay, one more. Astanika.
5, 5, 4.
Yes. Please do not. Do you know every year I have students that skip this? And I'm not sure where I'm messing up because it's got to be me. It's got to be something I'm not saying correctly. But every year I have students that skip this section on the test. because they just don't remember this. But I don't know what I can say to you to help you remember this, but it shouldn't be hard. The top exponent should fit right here in every one of them. See? 7.
I think for me, if I could just remember that degree and power is the same thing, then it would kind of fall into place for me. And then make sure they go descending.
Right. Make sure they're descending. And then the turning points is always one less than whatever these are over here. Okay? All right, let me show you what your assignment looks like. And there's a couple that I need to do with you. The first part of this is the support for 8.1. Do you see what it looks like? They give you an equation. They want the leading term, the leading coefficient, the degree, and the name, just like we did. That's what everything is on here. Now be careful. Sometimes they're out of order. So you have to put them in descending order first before you can find that leading one. But every problem is like that. And these are the same problems that we did tonight on the chart. So we did that whole section. Okay, now let's look at this one. This is the 8.1, and this is the way it looks. All you have to do is identify your leading term, decide if your exponent is odd or even, and decide if your coefficient is negative or positive. And then you pick the right picture. We have an odd leading exponent and a negative leading coefficient. So we're looking for odd and negative. So it's going to be this one right here. And those are all the same way. That's what that is. We did these tonight. These were our examples that we did tonight. We already did those. We did this one. This is a substitution. We did the multiplicity one. We did find the zeros. We didn't do this problem number 8. We might need to look at it. We did not do that specific problem. This question over here is about going through, crossing through it. Crosses through it if it's odd. It's tangent to it if it's even, if the exponent's even. So those, all the other problems except this number 8, we have done tonight. So let's look at this number 8 that's on this 8.1. This number 8 says find the zeros. And you have f of x equals negative 8, parentheses, x minus 4 to the 3rd, x plus 3 to the 4th, x squared. Okay? We have to fill in these blanks. The 0, 4 has multiplicity blank. Blank is a 0 of multiplicity 4, and then the remaining 0 is blank. It has multiplicity blank. So you have to fill in those blanks. Okay, let's see what we have to do. The 8 has no variable. See, there's no variable on that 8. See that? So don't worry about that 8 at all. Just take it out because it has no variable. Okay, let's do the others. You have an x minus 4 equal to 0. Add 4, x equals 4. And this exponent's 3, so the multiplicity is 3. Then you have an x plus 3 equals 0. Subtract 3, and you get x equals negative 3. And the multiplicity on this one is 4. And then you have x equals 0 from this one. And the multiplicity is the exponent, which is 2. So now we're ready to fill in the blank. The 0, 4, that's this one, has a multiplicity of 3. Blank is a 0 of multiplicity 4. So there's my multiplicity 4. The 0 is negative 3. The remaining 0 is 0, and it has multiplicity 2. You see how you fill that in?
So most of our homework is like fill in the blank, is that correct?
Yes, or pick the picture.
Okay.
That's why these two sections are easy, pretty easy, because you have to pick the picture. Okay, now right on top of this, they throw a section of factoring in here, guys. All of a sudden they go, oops, let me see if you can still remember how to factor. So I do want to warn you, there's a section of factoring on this. It's a pretty big section too. If you have a f of x equals x cubed minus 7x squared minus x plus 7, we have to factor that. Can anybody tell me, how do I factor something with 4 terms? We did this when we did AC trinomials. Do you remember? Let me help you. You group it 2 and 2. Does that ring a bell? Two here together and 2 here together. Now then you take out a GCF. So in this first one, we have XXX, we have a 7 and an X and an X. So they both have in common 2 X's, X squared. I'm going to take out an X squared. That leaves me 1 X here and a minus 7. The third term is negative, so you have to take out a negative something.
Negative 1.
Negative 1, and when you do, it's going to make it X minus 7. Now remember, we're trying to get these two little groups to look alike. Once they look alike, we are in good shape. So we have X minus 7 times X squared minus 1. Okay, we are trying to find the zeros. And the multiplicity. Okay, so we have to figure out how to set these equal to 0. X minus 7 equals to 0. Okay, and here's an x squared minus 1. We could break that one up into x plus 1, x minus 1, or we could set it equal to 0 and use the square root rule. So let's figure this one out first. This is x equals 7, and there's a 1 understood up there. So this is multiplicity of 1. There's only one of those. On the x squared minus 1, we can do x squared equals 1, x equals plus or minus the square root of 1, x equals plus or minus 1. So we have x equals 1, x equals -1, multiplicity 1 for both of those. Now, if you didn't want to do it that way, you could come over here and factor this into x minus 1, x plus 1, and then set each one of those equal to 0. Gives you the x equals 1 and x equals -1. And again, the multiplicity is 1. You can do either way for that last one. Okay. This is old material. We've done this before. We've factored. The only difference is now they're asking you for the multiplicity, which is these little tiny exponents outside here. What are those numbers? Is this going to go right down through your graph, or is it going to touch? If it's an even multiplicity, it touches. It's tangent. If it is an odd multiplicity, it crosses, goes down through it and intersects it. Okay, guys, that is it. That's all the new information for 8.1 and 8.2. I can work, let me see, I can work a few, for those of you that want to stay, I can work these problems that are factoring problems. This is for the support section for 8.2. They're all factoring. We can work some of those if you want. Look at this algebra, college algebra section for 8.2. All you're doing is finding the number of zeros, the number of x-intercepts, and the turning points. Look how these numbers are, 11, 11, 10. And we did these on our exercises tonight. So the only other thing that I can think of that you might need to know is on these graphs that are big, you might need to look at your number on the end to see where it crosses the y-axis. Sometimes you might need to do that. Like on this one, there's no constant term, so that thing has got to go through 0, 0. Other than that, I think you've got it. If all else fails and they're asking you for the graph, do you know what you can do?
Plug it in your calculator.
Plug it in your calculator and look at it. If you can't just do it from what we learned tonight, then just look at it on your calculator and you'll know which one it is.
I had to do that on the test, but then I like zoomed in because I almost missed one. I had to like zoom in on the multiple choice ones because some of them are very similar.
See, these are all very different graphs, so you should be able
this section seems a little better on this.
You should be able to just look at your graph and go, oh, well, I know which one is that. But we could do it anyway because look, the equation for it is 1/5 x squared minus 5. Well, the x squared tells you it's a parabola, so it's not this one or this one. The 1/5 is positive, so you know it's going to smile, so it's got to be this one. That's the only choice you've got. You don't even have to spend time graphing it. Just look at it. Okay. All right. Do we have any last words of wisdom before I'll stay till 8:15 and work on these problems that you'll need to factor if you want me to do that for a few minutes? Does anyone have any questions or comments or anything before we do that section? And those of you that don't want to watch the factoring can drop off and go do your homework probably. Thank you all for coming. It's such great attendance. You know, I think we've only got one absent tonight. Well, 2 if we count Braylon. Braylon is off being the Army man. He is off on a detail that he won't be back. He probably will not be back to our class, but he's going to finish the course. He's just going to do it from the desert. So
Oh, wow.
Yeah, I know.
Oh, he's in the military.
He's in the military, yes. Yeah, we're gonna miss Braylon. He's a good student. But he's gonna finish. He's just not gonna finish it with us. I see a kitty cat.
Cat wants to learn math, guys. He popped on my lap. Benny, say hi.
That's a curious cat. All right, do we have any other comments before I start working these problems for that are factoring?
You do my factoring for me? Bye, guys.
Okay, if you want to stay, stay. If you don't want to stay, then you can do your factoring on your own. We've done it many times, but I'm going to start doing a few. You can drop off when you want to. This is actually 8.2, and it is the support group for 8.2. Can you see that pen? Yeah, I guess you can see it. It says factor. This is number 1. And you have x times y minus 3 plus z times y minus 3. So all you have to do to factor that, these y minus 3's match. So it's y minus 3 times x plus z. There you go. Now this number 2 is factor. And you have 5x times 3x minus 4 plus 2 times 3x minus 4. See how the little groups match? Those make 1. So you have a 3x minus 4 and a 5x plus 2. And we'll stop there and make sure you can do that one. Can everybody do those two?
Yes, ma'am.
Okay. All right. Good deal. Sequela, are you still here with me?
Yes.
Okay. Did you catch those?
Yes.
Okay, good. All right. Let's do number 3. Number 3 says factor. And you have x cubed plus 7x squared minus 7x minus 49. And it's not grouped for us yet like those were up there, so we have to group it. Group it 2 and 2. And this is a 3 here. So we have 3 x's, x, 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 and a 7 and 2 x's is what you have on that one. So it looks like they have in common 2 x's. So you can take out an x squared and you'll have an x plus 7. Now notice this negative third term. That means I have to take out a negative something. This one over here is 7 times 7, and this is 7 times x. They all have a 7 in common. So I'm going to take out a negative 7. That will leave me with x, and it will change that minus to a plus because I took out the negative. And notice how when I do that, these two little groups just magically are the same. So I have x plus 7 times x squared minus 7. Isn't that cool? All right, let's try another one. This is factor. We have an 8r cubed plus 24r minus 28r squared minus 84. So now they're going to give us a challenge. They're going to give us some numbers that are much bigger. Now, one thing that we haven't really talked a lot about is that sometimes you can take a GCF out of all of them first. Well, they don't all have an R, But let's check out 8 and 24 and 28 and 84. Can you think of a number they might all have in common?
Four.
4. So we could take out a 4 out of all of these to start with. That would give us a 2r cubed plus 6r minus 7r squared minus 21. Okay. Now just save that 4 there for a minute and we'll bring it down. We're going to group this 2 and 2. Now I have a 2r cubed plus 6r. I can take out a 2r and I'll have an r squared plus 3. My third term is negative, so I've got to take out a negative something. 7 and 21 have a 7 in common. And I have an r squared. The minus comes out and makes that a plus 3. And notice how magically those two little groups are the same. So now I have an r squared plus 3 as one group. That's my little squiggly group. And a 2r minus 7 for my other group. And I can bring my 4 down and not throw it away. So there's my 4 that was up there, and I brought it down. So now I factored it. Any questions about that one? We good? Kiana, are you good? These are all worked out for you in the assignment. All right, let's look at number 5. Number 5 has a different wording. It doesn't say factor, it says solve. And they give us v squared plus 4v equals 0. So we have to take out our v first, and we get v plus 4 equal to 0. Then we set each one of these little factors equal to 0. V equals 0 is 1, and notice that would be a multiplicity of 1 if we were thinking about that section. V plus 4 equals 0. Gives us v equals negative 4, and it has a multiplicity of 1. Those are the zeros. Okay, number 6. It's a solve problem. And you have 2r cubed minus 14r squared equals 36r. So this has that 36r over there on the wrong side. I need to bring it over and set it equal to 0 and put it in the right place. That's going to be 2r cubed minus 14r squared minus 36r equals to 0. So then I want to see if there's anything in common. It looks like they all have a 2 and they all have an r. So I'm going to take a 2r out of all of them first. And we have an r squared minus 7r minus 18 equals 0 when I take the 2r out. Now this goes back to the factoring. This is a simple trinomial. I don't have to do anything but make my two little parentheses here, but I do have to follow my rules. I must subtract factors of 18. The minus tells me I must subtract factors of 18 to get 7. So let's try 9 and 2. That would give us 7. I want my 7 to be negative, so I make my 9 negative and my 2 positive. And then I just put them in here. R minus 9, R plus 2. Now I've got this little factor, and this little factor. Notice these are to the first power, so their multiplicities, if they ask for that ever, would be 1. So I have 2r equals to 0. Divide out the 2, so r equals 0. Now r minus 9 equals to 0. Add the 9, and I get r equals 9. R plus 2 equals 0. Subtract the 2, and r equals negative 2. So there's my 3 zeros. Okay? Squela and Amanda and Morgan, how are you doing? Are those okay?
Yes, ma'am.
Okay.
I'm good.
Is it going too fast? Are you?
No.
Okay. All right, let's do number 7. See, this goes back to our old factoring rules. Number 7 says solve, and it has 10c cubed equals 160c. Okay, we have to set that equal to 0. So we have 10c cubed, and we'll subtract that 160 from both sides. We'll make it 160 negative over there. Now let's see what we can factor out of that 10 and 160. Probably 10 and c would come out. And I'll have it c squared minus 16. Now c squared minus 16 is a difference of 2 perfect squares. So the c squared factors into c, and the 16 would factor into 4 and 4, and you put 1 plus and 1 minus. That's the way you factor a difference of squares. Square root of 16 is 4, so that would be that, and then you've got the 10c that was in front of it. Now you've got the 10c, the c plus 4, and the c minus 4. So 10c equal to 0. Divide out the 10, and you'll get c equals 0 from that one. C plus 4 equals to 0. Subtract the 4, and c equals negative 4 from that one. C minus 4 equals to 0. Add 4, and c equals 4 from that one. So your zeros are 0, negative 4, and positive 4. Okay? That good?
Yeah.
All right, let's try one that's a little bit harder. This is number 8, and it does say factor. It doesn't say solve. We just have to factor it. V cubed minus 9v squared minus 9v plus 81 has 4 terms. So we're going to group it into 2 and 2 and see what we get. These two go together, and these two go together. I didn't have anything I could take out of all of them first. So I can take a v squared, looks like, out of this one, which will leave me with v minus 9. The third term is negative, and every time that happens, you have to take out a negative something. They have a 9 in common, so I'm going to take out a negative 9. And look, it's always magic. It looks just like that. You end up with a v minus 9 in both those little places. So I have a v minus 9 from the common group and a v squared minus 9 from that one. Well, look, that is a difference of squares right there. So I can keep factoring on that one. The v squared will factor into v and v. The 9 will factor into 3 and 3. And you put 1 plus and 1 minus. And that's the way that difference of squares factors. And the other one is that v minus 9 that was out in the front. Any questions? Okay, there's only a couple more. Let's see. We have b cubed minus bg squared minus 16b squared plus 16g squared. B's and G's all mixed up. Okay. Group them 2 and 2.
Yeah, put B instead of B.
It's got a b. So you have a b squared minus g squared. The third term's negative, so we have to take out a negative something. 16. And so we have a b squared minus g squared. See, it's magic. See that common one? So you have b squared minus g squared and b minus 16. Now b squared minus g squared is a difference of 2 squares. So you can have b and g and 1 plus and 1 minus. And then you have your b minus 16 over here. See how that works?
Yes, ma'am.
Okay.
Okay.
All right. Let's do at least one more. Okay, just one more. There's only 2 more. But let's do this number 10. 10 is a stinker, so let's look at it. Negative 5x squared plus 8x cubed plus 16x minus 10. This one's a little bit different than the others we've done. Group. And it looks like you have a negative first term here. So you could take out a negative. I'm not sure what it's going to do over there. Let's take out a negative x squared and see what happens. That's going to be a 5 minus 8x. Let me send my daughter a message. Okay, and over here we have a 16x minus 10. So if we take out a net, we want our x's to be negative. So let's take out a negative something. A negative 2.
Take out a negative 8 or negative 2. Why couldn't you take out a negative 8 to make it? Never mind, because it's not going to be like if you take out a
8 won't go into 10.
Yeah, that's right. Okay.
So that's going to make it negative 8x plus 5. And that's what I want, because this one is 5 minus 8x. So I'm going to take a second here and rewrite that one. Negative x squared, 5 minus 8x minus 2. And I'm going to write this one with the 5 in the front. It's positive 5 minus 8x. So it'll look exactly the same. So just rewrite that last one. The negative is still with the 8x and the 5 is still positive, but now they look exactly alike. Do you see that?
Yes, ma'am.
So now we have negative x squared minus 2 and 5 minus 8x. That's your common one. Okay? Now, that is a good answer, so they should count it. But because it has all of those negatives in there, the author took out a -1 out of this one and made it x squared plus 2. And he took out a -1 out of this one and made it 8x minus 5. Isn't that crazy? He took out -1 out of both. And then this -1 times this -1 makes a positive. So you end up with x squared plus 2 times 8x minus 5. Now that is a tough problem right there. You shouldn't have one like that on the test, but that's just extra for your money. Now, you could have probably put this one in the system and it would have taken it, but I know that his answer didn't have those negatives in it, so he factored them out and then multiplied these two -1s together to make a positive one. All right, let's try one more and then we'll be done. This one is 5x cubed plus 30x squared plus 7x plus 42. And this is a normal one. We should be not having any trouble with it. So you take out a 5x squared and you have an x plus 6. And I'm hoping to get an x plus 6 over here on the other side. I take out a 7. I'll have an x plus 6. And I don't have to worry about negatives or anything. I think this is going to factor. 5x squared plus 7 is one group, and x plus 6 is the other group. And I don't have a difference of squares over here, so I don't factor this one anymore. That's it. And that's all of those 11 factoring problems that you'll run into. Any questions?
No, ma'am. Thank you. I want to make sure I have the hang of it.
All right. You have a great night.
I'm going to go ahead and drop off because I got some little ones to get in bed. Bye. Good night.
Good night. You guys, I'll see you Thursday.
Yes, ma'am. Bye.
Bye.
All right. Thank you.
You're welcome.